And good afternoon and welcome to my YouTube channel. And today we're going to be discussing the basic history of the Hydrolevel feeder. This is personal and is in no way endorsed by Hydrolevel. I might be in error on a couple of the facts. So if that is the case, I welcome any comments down below. So without further ado, we're going to jump right into it. So what I have here is a teal colored box of the same form factor as their later versions. The latest version of the VXT feeder is black, but the first ones they came out with were teal, and it's built around the S45 solenoid valve. You can see that's got, let's see, I can't really see it. It's got a lot of rust in there. This thing was definitely rode hard and put away wet. The original manufacturer of this valve was Eaton, that's Controls Division. I think I've had a couple of videos on this valve, and it's made of mainly non-corrosive material. And if you applied the appropriate voltage to it, it would allow water to flow through it. And so somebody at Hydrolevel had the brilliant idea, probably in the late 80s, near as I can tell, of applying a delay circuit. Now in the late 80s, the best off-the-shelf delay circuits were largely non-electronic. These are thermodisc products, and they are wired in a, I guess you call it a push-pull mode. So if you add the appropriate voltage, what would happen is that would actually cause a heater circuit to begin operating a thermodisc. So there was about a 2-minute delay. It says there, let's see, up to 2 minutes. And if you power it up with, so it was V24-1, and this was a V24-2, and the main difference was this handled up to 175 BTU boiler, and this can handle up to 450,000 BTU boiler. So I suspect the major difference was it would stay on longer because presumably that boiler was bigger. And so you power this up, this would begin heating, would kick on a bimetallic strip, which would then send the power to the solenoid. The solenoid would open. While that was occurring, it would also then start powering up this circuit, which would heat and then would then shut it off after an appropriate delay. So this was normally open, and this was then normally closed and then would open up. And this was a step forward in that it allowed the low water cutoff to shut the boiler down, but then it would not turn on and feed until an appropriate delay. So if the water eventually came back and turned off the low water cutoff before this started to energize, then it would reduce the likelihood of boiler flooding. So this was a step forward. And see, this one's, somebody had scribbled in there, so it's probably a serial number and a date code of January 1991. And I think the last time I saw one of these actual in operation was, I'm going to say, a good 15 years ago. It was still working. In fact, if you power this up, it does work, or at least it does turn on and then eventually turn off. The main downfall of this is that you had problems in that this circuit would not turn off, and so it would tend to flood the boiler. This would just keep feeding. There was no emergency cutout, so if this thing stuck open, you flooded the system. And that was one of the major weaknesses of this thing. Usually what I'll see is these things have been abandoned. Some of them were still online, but just simply disconnected. And someone usually had to pipe in a manual bypass, and so that's what they would use instead. And so this has been passed into history. This is the various patent numbers. Almost quaint now. I don't think anybody puts patent numbers on anything anymore, so that's see if you can read that, and that takes care of that. So there was a sea change about the late 90s. This was one of their first electronic ones. Now I've removed the valve. It just energizes it here. This was where it would go. You would add a signal here of the appropriate voltage. This is 120 volts, and you can tell by the power transformer. And here is a 24 volt version. See the comparison. And this one's date coded 1997, and this is date coded 1999. And I have seen, and I think I have a video of a unit very much like this one, still in operation, still maintaining the proper water level. This one had the major advantage of you could dial in the delay and the amount of time the valve stayed open. So you would use these dip switches to dial in the appropriate code. See, there's the appropriate, so you had the first four, or the first four did the delay from anywhere from 30 seconds to 10 minutes, and then you would adjust the amount of time it was on based on the results of the delay. So this was their first use of what we would consider proper electronics, and this is a major step forward. The main downfall of this device is that you really couldn't tell whether it was on or not, whether it was receiving a signal, and there was also no bypass where you could override and push a button to allow the unit to feed. That forced you to put in a proper bypass, which is usually to the good, and but at the same time, that was, I would consider, a weakness. So, and now this is the closer to what we would consider the modern VXT. This is date coded November 4th, 2002, and it has 3 wires instead of 2. So you have your power unit, so you lit up your display. This was the first one with a display, and then you had your trigger, which was red, I believe. Let's see if that's correct, and it doesn't say that, but I'm gonna guess that is the case. And you had your dip switches, although you could tell now without the cover what the dip switches do. Very similar to what's In the more modern units, there's your display reset. This one is select for delay 30 seconds to 10 minutes. And then you had the low water cutoff, 1 gallon up to 5 gallons. There's your processor chip, resistor, bank for running the 1, 2, 3, 4, 5, 6, 7 element display, and MOSFETs and your voltage dividers. I do not have a version of this in 120 volts, but this one does work. I've bench tested it, and there's your S45. This one is the Invensis version with the strainer and the built-in flow restrictor disc in the unit. And as you can see, it's new in the box, but I would probably not put this unit in. This is going to remain a museum piece for now. And just to bring it up to the modern day, this is the 120 volt version. The dip switch manufacturer has changed. There's a little bit change here, and the major thing is you have a solenoid style relay, and there's your quality control checklist on there for when this board, probably made by a subcontractor, is then mailed to the factory in North Haven to be assembled onto their it's the same the same box, really. And that is a brief outline of the brief history, as I understand it, of the Hydrolevel feeder, the best steam. Oh, that's right, got your rocker switch here. And this is the first generation, and with the feeder switch there. And again, this is the best feeder on the market for steam boilers, and I think we've had other videos discussing that, but I thank you very much, and I hope that this was useful, and I, again, really appreciate your guys' support, and I thank you very much.